Hello, we're looking at example 6 found on page 73 of your pre-calculus part 1 textbook. This is in section P-6, rational expressions. This one is talking about how to subtract, and this works the same thing for addition as well, but how to subtract a rational expression that has common factors, that has no common factors in their denominators. And what happens here is, in order to be able to add or subtract rational numbers, the denominators have to be the same. So what they're trying to say here in the blue is that this one is 2x plus 3, this one is x plus 3, and then together these are, we're going to combine those together to become one big common denominator. Now, the top one, the x plus 2, already was over 2x plus 3, so what we have to multiply by is x plus 3 here. So if I multiply the x plus 2 by x plus 3, because it was over a 2x minus 3 already, it wasn't over x plus 3. So to balance that out, I have to multiply the top by x plus 3. In that same fashion, since 4 was over x plus 3 and I have x plus 3 in my denominator, then I've got to multiply the 4 by the 2x minus 3, which was the other one. It's a way to kind of balance everything out. Now, when I combine these together, first of all, these two right here, you have to do the FOIL method, which is the first, the outer, the inner, and the last. And you end up with x squared plus 5x plus 6. You're subtracting, the 4 gets distributed to both of these numbers, so you're really subtracting 8x minus 12, and that's why there's parentheses around that whole thing. Now, when I clean this up, minus 8x minus 12 here is the same as minus 8x plus 12. And when I combine that together, I get x squared minus 3x, that's the 5x minus 8x, and then the 6 plus 12 ends up being 18. Now, when you do that, what you're going to find out is that your answer still looks fairly complicated, but at least I was able to add those together because I had a common denominator. So your final answer does end up being x squared minus 3x plus 18, and then that's all over 2x plus 3 and x plus 3, or 2x minus 3 and x plus 3, excuse me. Now, as always, you have to give the excluded values. So if I were to set the 2x minus 3 equal to 0, that's where you're going to end up with the answer x cannot be 3 halves. And if I set x plus 3 equal to 0, then of course x cannot be negative 3. And you must list those collectively in there. All right. So let's do the same thing with the checkpoint number 6 here. The common denominator is going to be x plus 1 and x minus 1 together. Okay. So I kind of do it this way. I put them both over x plus 1 and x minus, not 5, 1. Now, because this one already has an x plus 1, all I have to multiply is the top by this number right here. So it becomes 3 times x minus 1. And since for the second one, this one was already x minus 1, then I'm going to multiply the top by x plus 1. So this one becomes 5 times x plus 1. Again, that's a way to balance everything out. Now, don't cancel anything at this point. Multiply them together. You're going to have 3x minus 3, because you've got to distribute that, plus 5x plus 5, because again, you've got to distribute that to both of those. And remember, now that they have a common denominator, it's going to all be over x plus 1 and x minus 1. Now, if I can clean this up just a little bit, 3x and 5x is going to end up making 8x. Negative 3 and positive 5 is going to end up being positive 2. And then, of course, that is all over x plus 1 and x minus 1. Okay? So we can leave that as our final answer. Now, again, remember, you've got to list your excluded values. X could not be negative 1, and x cannot be positive 1, because either one of those could create a 0 in the denominator. and those are called, I'll just abbreviate, but those are called your excluded values. All right, hope this was helpful.